Data structures are a way for you to organize the data of your application. Toddle comes with two built-in data structures, arrays and objects. Let's dive into how to use these in Toddle. So the first data structure we want to talk about is an array. An array is simply a list of items, and arrays can contain pretty much any kind of items, including objects, including other arrays. Let's go and create a variable called array, and we're going to use a formula to define its initial value, and we're going to use here the array constructor. So right now this creates an empty array. We can add items into this. I'm going to add Andreas, and let's say Casper, and we'll add Jacob. So this will right now be a list of, and we can add a few more. Let's just add Marcus and Eric, right? So right now this array is an array of toddle employees. And I can now go here in Toddle, and I can go and say, let's repeat this list item based on our array, and maybe use the formula here to pull out the item, right? So we can use our array in Toddle. For example, for repeat is a very common use case for arrays. Arrays also comes with a ton of different formula operations we can do on them, right? So one very simple one is we can say get, and then I can access a specific item from the array. And you notice here on the left, we've got these little numbers. So this is the index for each item. So an index is the position in the array where each item is. So if I say, for example, 0 here, I'll get out the first element, and then 1 for number 2, 2 for number 3. And this here, whole thing, it being 0 index, or starting at 0, can seem super weird when you're first learning about it. This is the same in every programming language, and it's super weird for every developer who learns it right away. It turns out, as you kind of get into working with arrays, and especially using formulas and different kind of dynamic ways of accessing data from arrays, it actually makes a lot of sense, but it's totally natural that it feels weird right now. So it's kind of just something you learn, and then relatively quickly you don't really think too much about it anymore. But yeah, we can use get as a formula here to access a single item in the array. There's a similar one called set. And set here doesn't return the item it's set. So sets obviously changes that item in the array. So here it just returns a new array with that item. And it's quite important to understand it's a new array. So let's say this formula was not us defining the initial variable. We actually, instead of defining an empty array, use the value variable array here, right? In that case, it wouldn't automatically change the variable just because we use set inside a formula. To change the variable, you need to use the set variable action, right? This just returns a new array where that value is set, but it doesn't actually change any of the data on the left side. And it doesn't even change it inside here. So if I have like a variable for this, I can access that variable again. It's still going to be the old data. It's only here on the output where it's changed, right? And of course, both the path here and the item can be a formula as well, if you want to use it based on some other data you have available. We also have delete. So the last one here, it does kind of what you probably would expect. It removes that item from the array. So based on the index, we can go and say, I don't want Jacob in this array, so it cuts it out, right? In addition to that, there are some list operations that are quite commonly used on arrays. One of the popular ones is called map. And what map does is it takes each item in the array and then it actually applies this formula here that you have down here, and then returns a new array where each item is the result of this formula. So right now the formula is just a string 2, so every item is 2. But you can see now, if I'm opening and building this part of the formula, now I have these two arguments of item and index. That item here represents the item in the array. So if my formula just says item, it's going to be all the names just as the word. But if, for example, I add upper case here, right? Now I'm getting a the uppercase value of all these strings. So you can kind of think of map as a way of saying, if I have a formula and I want to apply it to run through every sort of item in the array, I can use map to actually achieve that. And so map is, you see it in a lot of programming languages as well. You might already be familiar with it, but it's this idea of creating an array that looks exactly like the first one, but every single value has had a formula applied to it. Another really common one is filter. Now, filter, as you can see here, doesn't change the array at all. What filter does is it sort of runs a filter over the array to decide whether it should keep values in the output array or not. And so in this case, we can say false. We can say false. And that just means whenever that formula here is false, it won't be returned in the output filtered array. So I can say, let's say I say argument equals Andreas. Then it's going to return an array with only this one, because that's the only one where this was true. I could change this to not equal, and then it's going to return all the other one. So this is really useful. Let's say you got some data and you got some filters on your page, and you want to turn on different kinds of is this that kind of value, or maybe you have a search filter where you want to say includes, and then you have like a search string like A and D, right, or includes R. So these are all the values that includes the letter R, right? And of course, this R could actually be its own value from somewhere. So you can use this for doing live search, type ahead, all sorts of things, and then take the output result, and that's actually the thing you then repeat over, right? The last one that tends to be, there's quite a lot more, and I will add some more videos eventually around more list operations that are quite useful. But one more that's sort of particularly often relevant is find. Find works a little bit like filter, but the first time it's true. So for the first time it finds an item where it's true, it returns that item instead. So in this case, even though there are actually three, it just says the first one. It just stops at the first one and says, okay, there it is, right? So it lets you find an item inside an array. And it doesn't return an array, it returns just the item. Right? Great. So we've talked a little bit about arrays. Let's have a look at the other data type in toddle, which is the object. So objects, and you can see this actually looks, let's go and just reset this a bit. Right? Objects are actually quite similar to arrays. But rather than having indexes for all the different keys, it has these string keys instead. So rather than having 0 and 1 for Andreas and email, we gave those indexes name. And now their order doesn't matter anymore. It's not like name comes before email. They're just different values. Like name is a different concept than email, right? And you can kind of think of an object almost as having separate values, but grouped together in a structure, right? So this is obviously very useful if, let's say, you have a list of root users like we did before. Let's go and do that. Let's just copy this one and then put that into our array, right? So let's say here we could do multiple users. Oops. And then instead of just having our name, which is quite limiting, maybe we want to show more information, we can actually add multiple bits of information for each user while still maintaining our array, right? And we can still do all the same list operations. So let's go and have a look at our page now. Now it just says weird object. We can change this formula to actually say, I would like you to get the name, and then maybe we add a span inside where we extract the item email, right? So now we have more information about each item in our array because we use an object, that object data structure to store that, right? Just like with the array, we can use basic get to get an item, in this case name. Now we're getting them by their string path or their string key, right? Or email. And of course we can also use set to do the same. And I'm setting email to item, or you can even delete the email and it'll just have the name, right? We can also, let's go back a bit. We can also, as I said, mix and match objects and arrays. You can also add like stuff. Right, we can add arrays inside objects inside array. You can kind of structure this however you want. And we generally refer to this concept as data modeling, when you're taking and building up your structure of arrays and objects to actually build, as I said, a structure or a model of what your data should be. So, and there's many different ways. This is kind of sort of a practice you can study for a long time, right? Of figuring out what is the best way for my app to model the data. How do I best store the data in service of my application, right? So maybe in this case, it makes a ton of sense to have an array of users with name and email, but there might be another case where you actually would want to have an object here instead of an array. And then actually give them ID1 and ID2, because that makes it kind of easier to access, maybe not ID1 twice, because that makes it easier to access these two things directly. There's a tons of different scenarios. It kind of really depends on what you're building, right? I'm jumping back to the array, and we'll just get rid of this. The get and set methods also works on nested data structures. So right here we could say I could get 0, and that will return number 1, and then I could run get again to get name, and that's a perfectly fine name to get the name of the first user. But I can actually also get rid of this and then use an array as my path, and then just give it 0 and name. And that also works. So it can go deep into this data structure and say, I want to get just this value in here, right? And this also works with set, new name. So now I'm going in here, and it sets just the name to new main and leaves everything alone, right? And I can of course also do the same thing with delete, right? You often see when you have this sort of data structure, an array of objects is extremely common. You will, if you haven't already run into a scenario with that, you will undoubtedly see it very soon. Most data, a lot of times data returned from an API will be an object at the root, and then you usually have some sort of list structure in there of the items being returned, and each of those items are almost always an object, right? So you'll always see this sort of nesting of data structure, and especially this objects inside array is extremely common. And one of the common patterns we see here especially is having this, like getting, let's say we're getting all the items out of an object. You want to be able to create a select list with all the names. So being able to just get all the names from an item like this, we can use the map we introduced earlier as a really easy way of doing that. So the last thing I want to show is we can convert between the two relatively easy. We have a formula called entries, and what that does is it takes an object and then converts it into an array of objects, where those objects have a key and a value key. And so this basically allows us to do list operations on objects. So let's say I want to filter out now. I can now filter. Well, I can just show you first. We have a from entries, which does exactly the opposite, right? So when you have these two next to each other, they basically cancel each other out. But in between, I could choose to say filter, and then say if the key equals, or let's say something like starts with n, right? And this sort of is a very thought up example, right? But basically saying, get me that object, but only include all the keys where the name starts with n, right? And there's a lot of different things. Any sort of list operation you can do now, you can now actually apply to these pairs of key value pairs in the object. So you can use this to construct dynamic object, again, filter, map, anything you like. Right? So this is just kind of some of the operations and some of the things where you can use object and how you can use them in toddle. There's obviously a lot more, but hopefully this gave you a little bit of an insight into what's possible working with data structures in toddle.